So today I am going to explain E1-CB reaction. So what is the meaning of E1-CB reaction? We have already discussed regarding E1 and E2 reaction. So there are one special kind of elimination reaction. It is known as E1-CB reaction. In E1-CB reaction, what is the full form of E1-CB reaction? It is one kind of elimination reaction, and one means unimolecular. But in this case, CB means conjugated base. It means it is unimolecular elimination reaction via conjugated base. So it is known as unimolecular elimination reaction via conjugated base. It is a special kind of elimination reaction, and in this elimination reaction there are 2 or 3 more important points. Is this reaction occurs via conjugated base, and this reaction occurs in 2 steps. Occurs in 2 steps. Get always here Hoffman product. We always get Hoffman products. You know very well, in elimination reaction we get 2 types of product. Either it will be Setzer product or it will be Hoffman products. And in E1-CB reaction we always get Hoffman product. It means there is terminal double bonds, and it is our major product. Why, we can discuss regarding it in further. So now we understood this E1-CB reaction. We have already discussed it is 2 steps reaction. So in this 2 step reaction, for example, here we consider one more example. Suppose it will be 2-fluorobutane. This is step 1. In step 1, it is the 2-fluorobutane. You know very well, in elimination reaction there is alpha beta elimination. So F is our living group. This one is our living group, and this is the, you know very well, alpha position, and this one is the beta position. Here already hydrogen is present, and here is also hydrogen is present. So this one is the beta position, and this one is also beta position. Here F is the living group, but you know very well F is the poor living group. So we can consider one point here. This reaction occurs in the presence of always poor living group. This is the condition of this reaction. If there is a poor living group presence, then E1-CB reaction occurs. And second criteria is this reaction occurs in the presence of strong base. Now we explain it. So here we have 2 beta hydrogen. So in the first step there is in the presence of strong base. Suppose we have here tertiary butoxide. We have a tertiary butoxide, and you know very well tertiary butoxide is a strong base. So what is the role of base? You know very well, base abstract a proton, and here we have a 2 beta protons. So there are 2 possibilities. Either tertiary butoxide attack on this place and this beta hydrogen. Suppose we can say it is the A root, or beta hydrogen can attack, and second position means second beta hydrogen, and this one is B root. So if tertiary butoxide attack on this hydrogen, then it will be removed as a proton, or we can say here second possibility. So here 2 possibility. What we get, product A and B. So in this condition, suppose this one is A, and so there will be a negative charge on this carbon, means terminal carbon, and we can say here there is the cation formation, cation formation, and this cation formation by A route. Or we can say second possibility is cation form on this carbon. Cation is formed on this carbon. In both are and this one is which one? B route. Now there are out of these two possibilities, which one is our major product, or we can say which one is our major more stable carbanion. You know very well stability order of the carbanion. 1 degree is more stable than 2 degree. It is the opposite from the stability of cation, you know very well. So this carbanion is 1 degree terminal, and this one is the 2 degree. And you know very well stability of carbanion is 1 degree is more stable than 2 degree. So we can say here this one our major, this one is our major, means it is more stable carbanion, and this one is the least stable carbanion. So this one is our major. So here we can say in first step there is our base attack on the beta hydrogen and we get the carbanion. And this step is also known as a acid base reaction. This step is also known as a acid base reaction, because this is there is removal of proton, and removal of proton we can say it is act as an acid, and we accept this one is accept the proton, so it will behave like a base. So we can say this first step is the acid base reaction. Acid base reaction, and acid base reaction is always fast. So this step is also we can say fast step, and fast step, so it is not a rate determination step. It is not a rate determination step. And so acid base reaction, and this one is fast step, so it is not rate determination step. And second important thing is in this step carbanion, intermediate is formed. Carbanion intermediate is formed. Okay, so in first step there are two phenomena occur: removal of protons, and one most important thing is after removal of proton, it is the very well acid remove the proton and form a conjugated base. You know very well base by accepting the proton it will form the conjugated acid. So this one is our acid, like, and so this one is also we can say what one, which one? This is the, we can say it is also conjugated base. So in first step there is formation of conjugated base. So this step is known as removal of proton. From substrate, and formation of conjugated base. So this one is also known as CB, means conjugated base. Now in second step, in step number 2, step 2 is also known as a removal of living group. Removal of living group. We have already discussed we have poor living group. So due to this poor living group, there is no first step removal of living group, but in second step removal of the, so we consider here our measure first degree. So we consider this one here, and this one is chlorine, and this is carbanion. This one is carbanion, and here our chlorine is our living group. So in second step now, removal of this fluorine as a leaving group means F minus, and this one is the slow step, and you know very well slow step is always rate determination step. Clear? In this step we get the finally our Hoffman product. We get the Hoffman product. Here we get the Hoffman products, and this one is the slowest step. So we can say it is the rate determination step. Clear? This one is the rate determination step. So finally we can say even CB reaction occur in two steps. First step is removal of proton from the substrate and formation of conjugated base, or we can say carbanion. And this one is here we get the major carbanion, which is more stable. In second step there is removal of leaving group, and we can say and formation of pi bonds, and we get the alkene. But here we get the Hoffman product is the major product instead of Sacher product, because you know here 2 degrees less stable. If there is removal of leaving group from this one, then we get the Sacher product. But this one is less stable. So here removal of the leaving group from this one means primary carb anion. So we get the terminal alkene, and in this terminal alkene we get the Hoffman product. So now we discuss the rate of reaction regarding the even CB reaction. So we have already discussed first step is the fast step, because it is acid base reaction, and acid base reaction is always fast, so it is not rate determination step. And second step, removal of leaving group, is the slowest step, and it is a rate determination. But here remember very well, rate of the reaction is depends on both, means it is depends on substrate or alkyl halide as well as our base. Remember very well here, rate of reaction depends on both substrate, concentration of substrate as well as concentration of base. It means this one is with respect to Rx first order, with respect to base first order. So we can say order of reaction is 1 plus 1, means it is a second order reaction. It is the second order reaction. And second important point here, molecularity. So here molecularity is, remember very well, 1. Because second step is the rate determination. In second step, you know very well, only one substrate is involved, not a base. So we can say its molecularity is 1, and its molecularity is 1, so it is known as E1. It is known as a E1, unimolecular. So we can say it is the unimolecular. So now we will understand very well. E means it is one kind of elimination reaction, and here molecularity of the reaction is 1, so it is the unimolecular reaction, and this reaction occur via conjugated base. So we can indicate CB. So it is E1 CB reaction. So here we can say rate of reaction depends on concentration of substrate, means in case alkyl halide, substrate as well as concentration of base. It means if we increase the concentration of substrate, that will be increase the rate of reaction, as well as if we increase the concentration of base, then this reaction is also rate of reaction will be increased. So it depends on the both. So finally we can conclude this reaction occurs if there is more electronegative group presence, if there is more electronegative group or atoms are present, then it becomes, then beta hydrogen becomes more acidic. Clear? Beta hydrogen means it becomes strong acid. Clear? If you know very well, electronegative atom indicate the negative inductive effect. So there will be easily removal of proton. So we can increase the acidic nature of this proton. So if electronegative group आएगा, then reaction is fast. Clear? At that time reaction will be occur fast and it is a more acidic. Second important point. Generally, this reaction occur in presence of poor living group. Poor living group. Poor living group. We have already discussed living groups. Like हमने एग्जांपल में देखा फ्लोराइड्स F- as well as hydroxide as well as NH2- as well as NH2- और सभी जो पुअर लिविंग ग्रुप है वो पुअर लिविंग ग्रुप जो है उसकी प्रेजेंस में OH- और we can say also alkoxide ion RO-. So this all poor living group, in the presence of this poor living group, this reaction favorably evens the reaction. And third and most important parts, here we have discussed in first step there is carb anion is formed. So this carb anion is further stabilized either in the presence of electro-withdrawing group or by the resonance. So we can say form carb anion is more stabilized either through resonance. We will discuss about it later. Through resonance or by presence of electrons of electro-withdrawing groups. Here, so this is also three more important points regarding this even-Sebi reaction. If there is more electronegative groups, then beta hydrogen become more acidic, then reaction will occur faster. In the presence of poor living group, this is the most important criteria. This is the most important criteria for this reaction. Poor living group, F-, OH-, NH2- or minus, like poor living group favor this even-Sebi reaction. And third important point, carbon anion is further stabilized either by resonance or we can say electro-withdrawing groups का जो इलेक्ट्रॉन पुशिंग पुलिंग प्रोसेस होगा मींस इंडक्टिव इफेक्ट वन टाइम so it will be further stabilized, so this is the rate of the reaction. Remember very well, this is the second order reaction and molecularity is 1. Okay, so now we compare the even reaction, P2 reaction and even-Sebi reaction. So first step, you know very well, even reaction occur in 2 steps. This reaction occurs in 2 steps. In first step, in this case, in first step, removal of the living group and formation of carbocation. And in second step, removal of the loss of the beta hydrogen. Here, so we can say even reaction occurs in 2 steps. In first step, there is removal of the leaving group, and in second step removal of the beta hydrogen. Clear? And you know very well, even reaction is only occurring one step. This is one step reaction, and in one step reaction you know very well, leaving group as well as hydrogen both are removed simultaneously. Clear? Means both are removed in one step simultaneously, leaving group as well as proton. And we have already discussed, this is two-step reaction. In first step, there is removal of the protons. Remember that here in first step removal of the leaving group, and here in first step removal of the proton. And in the second step there is carbanion already formed, and in second step removal of the leaving. Clear? Removal of the leaving. So here clearly you can differentiate. इवन रिएक्शन टू स्टेप में होगा, लेकिन फर्स्ट स्टेप में लिविंग ग्रुप रिमूव होगा और यहाँ पे हाइड्रोजन रिमूव होगा, मींस प्रोटॉन रिमूव होगा, और सेकंड स्टेप में यहाँ पे प्रोटॉन और यहाँ पे लिविंग ग्रुप. एंड इन E2 reaction, both reaction occur in one step, means both are proton as well as living group, both are eliminated in only one step. Okay. Second important point is here carb-cation intermediate is formed. Here carb-cation intermediate is formed, and in this case we can say no intermediate, but we can say one kind of, but this reaction via transition step. This reaction occur via transition step. And here we can say here carb anion intermediate is formed. Clear? So this is the second point important. Third point. Generally we can say this reaction occur in presence of good living group. This reaction occur in presence of good living group like Br, Cl, I, OH2 plus, etc. Similarly, this reaction also occur in presence of the good living group. In this case, this reaction occurs in the presence of poor living group. Poor living group. Where, like we have already discussed, F minus, OH minus, NH2 minus, OR minus. Okay. This reaction occurs in the presence of the weak base. We have already and heating. And generally we can say polar protic solvent. And this reaction occurs in presence of the strong base and polar aprotic solvent. And you know very well this reaction also occur in the presence of strong base. And fifth one is important point is their configuration. So here we get the Setzer product. Because of very well carb-cation is formed, and due to the stability of carb-cation we get the Setzer product. Here we also get the Setzer product, means Measure product, and here we get the Hoffman product. So remember very well these things. Clear? So these 5 points which are differentiated this both the means E1, E2 as well as E1 semi-reaction. Clear? So 5 points. Remember very well. From this you can understand very well what are the difference between these 3 reactions. Okay, now we will do more practice regarding this E1 semi reaction. Okay, so we will understand more problem practices, means through we can understand even CB, even E2 reaction through examples. So here first one is the CH3, C double bond O, CH2, CH2F. So this is our living group, you know very well. This one is our living group, and this is the alpha carbon, and this one is the beta carbon. And beta carbon, there is only one beta hydrogen. So first, how can you understand this one is E1CB, E1 or E2 reaction? So here first the living group. Our living group is the poor living group. And you know very well, in the presence of poor living group, there is always E1CB reaction occurs. And this one is also strong base. So we can say this one is one kind of E1CB reaction. This one is the E1CB reaction. Now, in first step, this one attack on this hydrogen, beta hydrogen, and removal of the step 1, removal of the proton and formation of the carbon anion, CH3, C double bond O, CH minus and CH2F. And you know very well, there is the acetyl group, means carbonyl group, CH3, C double bond O. This carbonyl group is further stabilize this carbon anion. Here, this is further, this group is stabilize form carbon anion. Here, this group, because you know very well, this is this kind of resonance, so it is more stabilized. This carbon anion is more stabilized due to resonance effect of this group. So this one is our conjugated base, and you know very well, first group is the slow step, and second step, step 2 is the rate determination step. In second step, there is a removal of the living group. You know very well, there is removal of the living group, and this is our stable product, and we get the CH double bond CH to this alkene, and this one is our Kaufman product. Okay, and this is also stable alkene because it is further resonance due to presence of this pi bond, sigma bond, and pi bonds. This sequence, conjugated sequence. Clear? Now second example, CH3, CHOH, CH2, C double bond OH. It is one kind of beta hydroxy aldehyde. Clear? It is the beta hydroxy aldehyde. So this is our living group here. Hydroxy group is the living group, and this is our alpha carbon, and this one is beta, and this one is also beta. So there are two possibilities. Clear? So there are two possibilities. Second, hydroxide plus 18, both are here. So first we have to decide which one, E1, E2 or E1C. So here OH is our living group, and it is a poor living group. It is a poor living group. So we can say this reaction also occurs via E1CB mechanism. Clear? E1CB due to presence of this poor living group. Clear? And this one is also poor living group. And यहाँ पे हमारा जो base है वो strong इतना नहीं है, sorry, negatively charged. It means it is a strong base plus 18. Both are here. So, but there are two beta hydrogen. So there are two possibilities. Suppose this one is A, we can say this one is the B. So here we consider both carbon ion, CH3, CH, OH. Suppose this is the A root. This is our A root. And in A root, this is our carbon anion, C double bond OH, plus CH2, B root, OH, CH2, C double bond OH. This is our B root. And So now there are two possibilities, but out of these two, which one is our major product? Which one is our major carb anion? So it depends on the stability. You know very well, this one is the terminal. Sorry, this one is the terminal, means 1 degree carb anion, and this one is the carb anion. This is further stabilized due to this group. This is undergo like this one undergo resonance. So this group here we can also say this group is stabilized by resonance. Yes. So this is our measure. This one is our measure carbon. Here more stable carbon. So in second step we can say here removal of the leaving group OH minus, and here removal of the leaving group, and this step 2 redetermination step. This is the step 1. It is the first step, and we get this conjugated major CV, conjugated base, and we get the finally CH3 CH double bond CH C double bond OH. So you can see here this is not a Optman product, but it is the Setzer product, because due to more stabilization of resonance, more stabilization of this carbonide through resonance. So this one is our major product. Clear? This one is our major alkene. Okay, so you will understand very well. Clear? These two problems of even CV reaction. So now we do more practice. The third one is phenyl CHOH CH2 CH3. So here you know very well OH is our leaving group, and it is a poor leaving group, you know very well. But here H plus, our attacking reagent is H plus, and so it is not base, it is an acidic condition, or we can say this is the H plus, means we have a protic solvent, and due to this protic solvent में आपको पता है कौन सा होगा फेवरेबल मैकेनिज्म, पोलर प्रोटिक सॉल्वेंट है, या हीटिंग भी है. सो दिस रिएक्शन अकर वाया E1. Clear? This is occur via E1 because of protic solvent है यहाँ पे. Clear? And so you know very well. First there is protonation occur. There is protonation of this hydroxy group, and so CH OH H यहाँ पे lone pair use हो गया, so it will be a positively charged CH2 CH3, and this protonated oxonium group is removed, minus H2O, and we get the carb cation. And you know very well it is benzyl carb cation, and benzyl carb cation is more stable. And यहाँ पे भी आपको पता चलेगा इवन मैकेनिज्म है, क्योंकि यहाँ पे कार्ब केटाइन जो है वो कार्ब केटाइन इंटरमीडिएट फॉर्म हो रहा है, और वो बेंजाइल कार्ब केटाइन इट इज फर्दर स्टेबलाइज्ड बाय रेजोनेंस, यू नो वेरी वेल, इट इज मोर स्टेबल. एंड देन आफ्टर इन लास्ट स्टेप में क्या होगा, दिस वन इज अल्फा एंड दिस वन इज द बीटा कार्बन, एंड हाइड्रोजन इज रिमूव्ड, proton is removed from this beta position, and so we get the final product CH double bond CH3. Okay, so this is our final product. So this reaction, though there is presence of poor leaving group, but other condition, due to other condition, this is means other condition means protic solvent, so this reaction occur via E1 mechanism. Similarly, fourth example में हम देखेंगे तो यहाँ पे this one is our leaving group, and you know very well bromine is our good leaving group, you know very well about it. तो good leaving group हो पाएगा, तो E1 CB का तो पॉसिबिलिटी ही नहीं है, either it will be E1 or E2. So E1 or E2. तो second condition, if there is a polar protic solvent, then E1 reaction occur, and if there is a polar aprotic solvent, then there will be a E2 mechanism. So here we have a methoxide, CH3O minus. So there is no any proton, so we can say it is a aprotic solvent. So aprotic solvent होगा तो कौन सा mechanism favorable होगा? E2, good leaving group and aprotic solvent. If there is good leaving group and protic solvent, then it will be E1 mechanism. But good leaving group, aprotic solvent, then we can say this reaction occur via E2 mechanism. Clear? This is occur via E2 mechanism. And you know very well, here this one is our alpha and this one is beta, and this is also beta. और you know very well, E2 mechanism में यहाँ पे beta hydrogen as well as leaving group both are simultaneously remove होगा, और यहाँ पे आपको पता है कि ZZ जो प्रोडक्ट वो हमारे मेजर प्रोडक्ट होती है, and so we get the here CH3 CH double bond CH. It is our ZZ product, and this is our major product. So from these four example you can learn very well when E1 mechanism occurs, when E2 mechanism occurs, and when E1 CB mechanism है वो होगा. आप यहाँ वो प्रॉब्लम से क्लियरली अंडरस्टैंड करेंगे. ओके. Now we will understand more one typical example regarding E1 CB reaction. Here you know very well, chlorine is our leaving group, so obviously, and we have a polar aprotic solvent, and so this is E1 CB reaction. Clear? This is the poor leaving group. But one more important thing, here ethoxide in presence of deuterated ethanol, and then we get the deuterated alkene. But if we carried out this reaction, ethoxide in presence of ethanol, clear? Ethanol, then we get our simple alkene. Now why we get this product? This product? This is the very simple things, but we will understand why we get this product. So here we have CH2F. You know very well, in first step removal of proton, and we have a strong base ethoxide. In the presence of this ethoxide, first there is removal of the proton. Okay, there is the removal of the proton, and there is carb anion is formed. Carb anion is formed. C8 minus CH2. Now we have a deuterated ethanol. Now there is the role of this deuterated ethanol. This deuterated ethanol, where उसमें OD, this bond is very well polar bond. Oxygen is partially negatively charged and deuterium is partially positively charged. So this partially positively charged, this carb anion, there is exchange of deuterium. Here, so this bond is black, and here this deuterium is attached to carb anion. Means we have a CH, now D, and CH2F. And there is formation of further ethoxide ion minus C2H5O minus due to this one, and now further this C2H5O minus is abstract this proton and carb anion is formed. CD minus CH2F. last step में removal of this leaving group minus F minus, and we get the final product alkene CD double bond CH2. Clear? CD double bond CH2. So due to this butyrated ethanol, one more step, this one is involved here, and we get the butyrated alkene. So this one is the typical example of the E1CB reaction. So now we will understand about the when we get the Hofmann product, means less substituted alkene, and we get the Sedgwick alkene, means more substituted alkene. So we will understand by this example. Here X is our leaving group, and here this one is alpha carbon, this one is beta carbon, and this one is also beta carbon. Suppose we consider this beta carbon is labeled by A and this beta carbon is labeled by B. If our base first attack on this beta carbon, then we get this product B, and this is very well Sedgwick product. Here this one is very well Sedgwick product. And if our base attack on this A beta hydrogen, then we get this A product, and this A product is Hofmann product. Now, what is the role of leaving group for both kind of products, Hofmann product as well as Sedgwick product? Okay. Understand very well. This one is our leaving group. This is our alpha carbon. This is first beta carbon, or we can say this one is second beta carbon. And this is the hydrogen. This is the A group hydrogen, and here ethoxide attack on this hydrogen, and we get the Hofmann product here. And if ethoxide attack on this B hydrogen, then we get the Sedgwick product. Now, what are the percentage of A product, means Hofmann product, and B product, means Sedgwick product? It depends on the leaving group. So here we summarize through this table. If our bromine is our leaving group, then we get the 19% Hofmann product and 81% Sedgwick product. It means if bromine is the leaving group, then our major product is the Sedgwick product. Similarly, if chlorine is the leaving group, then we get the Hofmann product 33% and Sedgwick product 67%. So in this case also we can check if chlorine is the leaving group, then we can check our Sedgwick product is the major product. And now in third example, if we consider the chlorine as a leaving group, then our Hofmann product is 70% and Sedgwick product is only 30%. So in this case, we get the Hofmann product as a major product. Similarly, if we consider the dimethyl sulfide as a leaving group, then we get the Hofmann product 74%. It is also major product. And similarly, if we consider the trimethylamine as a leaving group, then we get the 95% Hofmann product and only 5% Sedgwick product. It means if bromine and chlorine, very well, both are poor leaving group. Very well. Sorry, good leaving group. These both are good leaving group. And S, Me and Me3 are poor leaving group. So we can conclude from this, if there is a good leaving group, like we can say Br, Cl, I, OH2 plus. Then we get the Hoffman. Then we get the Sedzeff major product. And if we have a poor leaving group like fluorine SMe2 NMe2 NMe3, sorry, then we get the Hoffman major product. Hoffman major product. And one more thing, if our base is more bulkier, then we get more Hoffman product. So you will understand very well regarding the concept of base as well as leaving group. So I have tried to understand very well regarding the even CB reaction. So here we completed totally elimination reaction, even E2 as well as even CB. This is the exceptional case, but in many exams you will see example regarding this even CB reaction. Okay, so thank you very much.